Right, so this is another question on trigonometry, and in this question it said that if cosecant A minus sine A is equal to small a, and secant A minus cos A is equal to B, then what is the value of A raised to the power 2 by 3 multiplied by B raised to the power 2 by 3 into A raised to the power 2 by 3 plus B raised to the power 2 by 3, right? So this is the question. We have to find the value of this expression here. Now, the start point obviously has to be these two equations that we've been given. And again, I've said this before, my first instinct is to reduce the number of trig ratios that are there in these equations. So right now we have 4 different trig ratios. We got a cosecant, and we got a sine, and we got a secant and a cos. So that's 4. Now ideally I would like to boil this down to as few as possible, right? So we know that cosecant A is equal to 1 by sine A. So that we know. And we also know that secant A is equal to 1 by cos A. So let's use these expressions instead of the cosecant and the secant that are there. So if I use this cosecant A is equal to 1 by sine A in the first equation, then it becomes 1 by sine A minus sine A is equal to A, which implies that 1 minus sine square A divided by sine A is equal to A. Now 1 minus sine square A is equal to cos square A. So what I get is that cos square A divided by sine A is equal to A, right? So let's leave it like that. So let's just put this on the side and hold on to it. Now with the second equation, I have secant A, so that's 1 by cos A. So 1 by cos A minus cos A is equal to B, right? So that's 1 minus cos square A divided by cos A is equal to B. Now 1 minus cos square A is equal to sine square A. So this implies that sine square A by cos A is equal to B. So this is the second thing we have found, and so let's hold on to that also. Now so we now know the values of A and B in terms of sine and cos, right? So what does A to the power 2 by, oh, I'm sorry. So what does A to the power 2 by 3 into B to the power 2 by 3 into A to the power 2 by 3 plus B to the power 2 by 3 boil down to, right? So let's look at these two terms first. So A to the power 2 by 3 into B to the power 2 by 3 is simply AB to the power 2 by 3, right? So you kind of know this, right? So A to the power m into B to the power m, well, this is equal to AB to the power m, right? So 2 to the power 3 into 3 to the power 3 is simply equal to 2 times 3 raised to the power 3. So you can check this out. So this is known. This is middle school mathematics. So I'm just going to rewrite this as AB raised to the power 2 by 3, and this multiplied by A to the power 2 by 3 plus B to the power 2 by 3. Now we have to be, now we'll just take care. So what we have is A. So A was equal to, I think it was equal to cos square A divided by sine A, right? This is A. This into B was sine square A divided by cos A, right? So this is A multiplied by B. This whole thing is raised to the power 2 by 3. And then this is multiplied by cos square A divided by sine A, this raised to the power 2 by 3, plus sine square A divided by cos A, this raised to the power 2 by 3, right? So this is this, I'm sorry, this is this, and this is this, right? So this is what we have. Now what we can do is we can cancel, there's a sine square A and a sine A, so we can just cancel out this sine, and we can it'll leave one sine A in the numerator, and we can cancel out one cos over here, and we can cancel out one cos over here. So this whole expression ab raised to the power 2 by 3, this just boils down to cos a into sine a raised to the power 2 by 3, right? As for the sum, let me just scroll down a little bit. Oh, that's the most I can do. So as for the sum, let me just clear this out. So we have that ab raised to the power 2 by 3 is simply cos a into sine a raised to the power 2 by 3. But we still have to calculate a to the power 2 by 3 plus b to the power 2 by 3. So let's do that now. So that is equal to cos square a by sine a raised to the power 2 by 3 plus sine square a by cos a raised to the power 2 by 3, right? This boils down to so using the fact that a to the power m that raised to the power n is equal to a to the power m times n. You know, this is standard mathematical fact. We can convert this to cos to the power 4 by 3a, right? So that's 2 times 2 by 3, and sine is sine to the power 1, so 1 times 2 by 3, that's sine to the power 2 by 3a, plus this is going to be sine to the power 4 by 3a. So that's sine square has, like, it's raised to the second power, so 2 times 2 by 3 divided by cos to the power 2 by 3a, right? And this comes down to sine to the power 2 by 3a times cos to the power 2 by 3a into, well, this becomes cos to the power 4 by 3a times cos to the power 2 by 3a, right? So this is, I'm just doing simple addition, you know, of m divided by n plus x divided by y, you know, that notation. So I'm just doing n times y, and so it becomes my plus nx. So this is how you do fractional addition. So that's all that I'm doing. It's just that the m and the n just look more complicated. Plus sine to the power 4 by 3a times sine to the power 2 by 3a. Now we also know that a to the power m times a to the power n is equal to a to the power m plus n, right? So we got two cos terms over here, and they're raised to the power 4 by 3 and 2 by 3 respectively. So this comes down to cos to the power 4 by 3 plus 2 by 3 a plus sine to the raised to the power 4 by 3 plus 2 by 3 a divided by sine sine a into cos a raised to the power 2 by 3, right? Now let's not forget the a times b raised to the power 2 by 3 that we had outside, right? So that was still hanging outside. So that was also cos a sine a raised to the power 2 by 3. So this term and the denominator here, they just cancel out. So they are gone. And what we are left with is cos to the power 4 by 3 plus 2 by 3. Now what's 4 by 3 plus 2 by 3? So 4 by 3 plus 2 by 3 is equal to 3, and 4 plus 2 is equal to 6. So that's 6 by 3, which is equal to 2, right? So 4 by 3 plus 2 by 3 is equal to 6. Sorry, it's equal to 2. So what we have is, what we are left with is cos square a plus sine square a. And this we know is equal to 1, right? So that whole expression, that dangerous looking expression, a to the power 2 by 3 times b to the power 2 by 3 times a to the power 2 by 3 plus b to the power 2 by 3, well, it just boils down to a simple 1, right? Now the point of these kinds of questions is to just make you comfortable with the idea of playing around with trigonometric equations. There's no groundbreaking truth in these equations. It's just to get you comfortable with the idea of playing with trigonometric ratios. So that was the question, and that's how it's done.